guys, welcome to part 2 of lesson 2.13. We're going to be integrating implicit functions some more, but this time we're going to be learning how to find particular solutions. And I want to just spend an extra day on this stuff just because, like I've mentioned in my last video, this is pretty important stuff on the FRQ. There's a lot of steps, but they're worth a lot of points, and if you just do a few of them enough, it'll really stick in your mind and be a great way to really make sure you guys earn as many points as you can. So let's go ahead and begin here. So for example 1 here, find a particular solution f of x equals y for the given differential equation given that f of 2 equals 3. All right, so our steps are going to be pretty much the same as last time with, I think, one additional one added in now. So the first step is to separate your variables. Oops. Okay, so the first thing I'm going to do is I'm going to multiply both sides by y squared. And that cancels that out, leaving me with y squared dy over dx equals 2x. And then finally we're going to multiply both sides by dx now, because I want all the x's on one side and all the y's on the other. So that's the end of step 1 there, separating the variables. All right, let's do step 2, which is where we integrate both sides. Okay, so integrating the left side, we end up with y cubed over 3. And integrating the right side, we get x squared, and we only need a plus c on one side, and I usually just put it on the side that has the x on it. And so that's step 2, which is to integrate both sides. Okay. Now, at this point, this is where we're going to do something that we didn't do yesterday. We're going to find the c by plugging in our initial condition. Okay, so my initial condition here is this is my x value and this is my y value. And I'm going to go ahead and plug those numbers in here. So if I plug in the 3 for the y and the 2 for the x, I can solve for c. This is 27 over 3, which is 9, equals 4 plus c. And if I subtract 4 on both sides, I end up with the fact that c equals 5. And then we have the following here, which is y cubed over 3 is equal to x squared. And instead of plus c now, we're going to have plus 5. Okay, but step 4 is going to be the last step, and that's the step where we're going to solve for y. So you want to get y by itself. So the first thing that I would do here is I would multiply both sides by 3. So when I do that, these 3's cancel out, leaving me with y cubed. And on this side, we're going to distribute, and we're going to get 3x squared plus 15. And the way that you get rid of a third power there is you take the cube root. And as you guys recall, cube roots don't require a plus and a minus. Only even roots do that. And so there is our final solution. So just to kind of refresh your guys' memory, separating the variables is worth 1 point. Integration is worth 2 points because you get 1 point for each side that you integrate. Plugging in and finding your c is worth another point. And then solving for y is the last point there. And so typically these end up being anywhere from 5 to 6 points. So that's example 1. Let's go ahead and have you guys try student practice 1. Pause the video here. When you unpause it, you will see the solution worked out. All right. So this one had a few interesting things come up along the way. First of all, did you remember how to integrate this? The first thing, well, actually, back up, even something before that, is to separate the variables, you needed to divide both sides by y squared first, which is why you get it looking like this. Okay? So that's weird thing number 1. Weird thing number 2 is, did you remember how to integrate this? That's where you change it to a negative power, then you add 1 to the power and divide by that value, right? After that, you're going to want to go ahead and switch it back. So put the y to the negative 1 on the bottom with a positive 1 power, and now we have negative 1 over y. So that part was kind of tricky. But after that, finding your c is pretty straightforward. Then we get back up here to this step. So the first thing I did was multiplied everything by a negative to get rid of this negative here in the front. And that gave me this new equation as a result. Finally, what do we do about this? Well, basically what I did was I just took the reciprocal, flipped it over, so instead of 1 over y, it's y over 1, which makes it just y. But if you take the reciprocal on one side, you need to take the reciprocal on the other, so that becomes that. Okay? All right, so that is student practice number 1. Let's go ahead and move on to example 2. Now, the other examples are just really more of the same thing, but the last 2 actually have something kind of interesting happen at the end. So let's see what happens with those next few. So once again, we're going to start by separating our variables. So for this one here, I'm going to want to divide both sides by 2y first. So these cancel out, right? And then I'm also going to want to multiply both sides by dx. That way these cancel out. And now I've got 1 over 2y dy is equal to 1 over x dx. And now I'm ready to go ahead and move on to step 2, which is integration. So that's step 1. Let's go into step 2. So I'm going to integrate both sides. Now the right side's kind of chill because it's just ln of x. The left side is a little bit unfortunate because since we have this down here, we're going to treat that like a u sub situation. So I'm going to say that u is equal to 2y, and then I'm going to say du dy is equal to 2. And I'm going to get that dy by itself so I can do my u substitution here. So anytime your denominator there is something other than just a single variable, you have to do u sub. All right, so this 2 here, I can bring that out to the front. And now I can integrate this and just call it ln of u. So now I've got 1/2 ln of the absolute value of u is equal to ln of the absolute value of x plus c. I'm still not done here, though, because we still need to replace the u with what we know u to be. U is equal to 2y. So I'm going to put that back in there, like so. All right, so there's my general solution, but the y is not by itself, but that's okay. We don't need to worry about that. So that's the end of step 2, is integration. All right, let's go ahead and move on to the next step, which is where we plug numbers in now to find our c value. So I'm going to be plugging in 1/2 for the y and e for the x. Okay. So we have 1/2 ln of 2 times a half is 1. Ln of e is just 1. That's a good thing to memorize. Ln of e always equals 1. Another good thing to memorize is that ln of 1 is always 0. Those are two really good ones to just have memorized. So we end up with 0 equals 1 plus c. After we multiply these, we just get 0 on the left side, right? And then subtracting 1 on both sides, we would end up with the fact that c equals -1. Now let's go ahead and plug that into our solution that we have so far. So here's where I left off, and before I found my c. So now we have 1/2 ln of the absolute value of 2y is equal to ln of x. And now my c we decided is -1. All right. Now we got to do the step where we get the y by itself. So let's do that. The first thing I would do is I would get rid of that half in the front of the ln there by multiplying both sides by 2. Oops. Not just a second power, it's times 2. So here these cancel, and this is going to distribute in, and I'm going to be left with the following. All right. Next, we're going to exponentiate both sides. Okay. Now on the left side, these are going to cancel out. And that's just going to leave me with the absolute value of 2y. On the right side, we cannot cancel this and this out. We can't do that because there's this -2 there also. So I'm just going to actually just leave it like that. Let's see, we have e to the 2 ln of the absolute value of x minus 2. All right. Now, as you guys know, when you have absolute value, you're going to split that up as two different equations. So we're going to have 2y is equal to a negative e to the 2 ln of absolute value of x minus 2. And then we're also going to have a 2y is equal to a positive e to the 2 ln of x minus 2. Right? And then we're going to divide. And that's going to give us two possible answers. Now, unlike yesterday where we just wrote plus and minus and we were done, today we actually have to pick one, and we have to pick the right one. So how do we know which one is the right one? So my answer is either this or it's this, and we have to know which one it is. Is it the one with the negative e, or is it the one with the positive e? So let's write that down as a question. How do we know which solution it is? Is it that one? Or is it that one? The answer to that question is plug in your initial condition and see which one works. Okay? So plug in your initial condition and see which one works. So the question is, when you get two answers, how do you know which one is right? And by the way, you're going to get two answers anytime you have absolute value, or another situation is square roots. But we'll do an example like that later. But when you get two answers, How do you know which one it is? The answer is plug in your initial condition to see which one works. So I'm going to plug in x, I'm going to plug in e for x, and I'm going to plug in half for y, and I'm going to see which one gives me a good solution. So here we go. Let's start with the negative one first. So I'll test this guy first. Y equals negative e to the 2 times ln of absolute value of x minus 2. And all that's over 2. Okay, so I'm going to replace the y with a half. And then I'm going to replace the x with an e. And then I'm going to see, does this actually work out? Well, remember, what is ln of e equal to? Ln of e equals 1. So I have, now 2 times 1 is 2, minus 2 is 0, right? So if I put this together, I just get 0. And anything to the 0 power equals 1. So I've got 1/2 is equal to, this is going to be negative 1 over 2. Now, is that a true statement? 1/2 equals negative 1/2? No, it is not. Therefore, I know that this is not the solution, and therefore, this must be my solution. So when you get 2 answers, how do you know which one it is? Plug in your initial condition. If it works, then that's the answer. If it doesn't work, then your answer must be the other one. Now, you could plug it in to check if you wanted to see if it works, but you don't need to. We only had 2 options, so if it fails for the first one, it must work for the other one. All right, so let's go ahead and have you guys try one like this. So this is going to be another situation where you're going to have 2 answers, and you need to decide which one is correct. So go ahead and pause the video and see if you guys can knock this one out. When you unpause it, you'll have the solution up. So due to lack of board space, I've only got the first 3 steps up to begin with. But so here is the expressions, separated variables. Here is my integration. Notice on the left side we had to do a u substitution. And then completing the integral, we have that. For step 3, we plug in our initial condition to find our c value, which I ended up with negative 2. All right, I'll now show you steps 4 and 5. So here's step 4, where we get the y by itself, and we end up with these 2 possible solutions, and now we have to see which one is correct. And I just realized that I left off the minus 5 on each side. Let me correct that there. So it's supposed to be a minus 5 here and a minus 5 here. All right, so now we'll see which one of these works based on plugging in the initial condition. So this time it looks like it's the red one, the negative one that works. When you plug in your negative 6 and your 2, once again, this whole thing just becomes 1. But there is a negative in the front, so it's negative 1. And then, when you have negative 1 minus 5, you get negative 6, and that's a true statement. So by plugging the initial condition into this one, that means that that must be the solution and not this one over here. All right? So we're going to do another one. This last one is another example. It's pretty similar to this one in that you're going to have 2 answers. You're going to check them. It's just that it's a different kind. On this one, we ended up getting 2 answers because of the absolute values. On this next one, though, we're going to end up getting 2 answers for a different reason. So I want you to see the other circumstance that can cause us to get 2 different answers. So let's go ahead and begin. So step 1 is to separate our variables. So I'm going to multiply both sides by 2y. Next, I'm going to multiply both sides by dx. And that gives me 2y dy is equal to cosine x dx. All right. Now the next thing we're going to do is step 2, we're going to integrate both sides. Now this side's kind of nice, it's just y squared. And this side's actually not too shabby either, it's just sine x. Finally, a nice integral, something we don't have to do u sub on. All right, so we're ready for step 3, and on step 3 we're going to plug in our initial condition to find our c value. So I'm plugging in -2 for the y value, and I'm plugging in pi over 2 for my x value. Sine of pi over 2 is 1, and -2 squared is 4. So solving for c, I get 3. And so my general solution in implicit form is that. But we have to get the y by itself, as you know, so I need to square root both sides. Now this is the situation where you actually get 2 answers again. When you take a square root, you always get a plus and a minus. And that's why we have 2 possible answers. Okay, so which is it? Is y equal to a positive square root of sine x plus 3? Or is y equal to a negative square root of sine x plus 3? We need to decide which one it is. And once again, the answer to how you determine that is really the same as the last time. You just plug in your initial condition and see which one works. Okay? I forgot, I'm going to put my minus there. I can't really tell if I put it there or not, so I'll put it there. All right, let's go ahead. I'm going to plug it into the positive one here, so let's see if that works for us. So I'm going to plug -2 in here. And then I'm going to do sine of pi over 2 plus 3. Sine of pi over 2 is 1. And the square root of 4 is 2. Oh, that's not true. -2 is not equal to +2. And therefore, this is not the answer, and it must be the negative version. So once again, there's another way. So there's 2 ways you can end up with 2 answers. One is with the absolute values, which we saw with the ln thing. And now we're seeing square roots can also create 2 answers. So I want you guys try one of those, and that'll be it for the day. So go ahead and pause the video here and see if you guys can determine the solution to this one. So I've got us up to step 4 here, and I end up with y is equal to either a positive square root of 2 e to the x plus 14 or a negative version of that. And so we're ready for that last step, which is where we go ahead and plug in the initial condition. I'll go ahead and plug it into the positive version of the expression there and see if it works. And if it works, well, that's my solution. If it doesn't work, then my solution must be the negative one. So I'll plug in 4 for y, 0 for x. This is just 1. So 2 times 1 is 2, plus 1 is 14. I'm sorry, plus 14 is 16. And the square root of 16 is 4, and that works. So I picked right, and that is my solution. It's not the negative one, it is the positive one. All right, and that is it. So hopefully that was helpful, and we'll see you guys in class to practice this stuff some more.